So today we will discuss about nuclei. The important topics are: first, size of nucleus. Second one is nuclear force, binding energy, mass defect, binding energy, curve, then nuclear fission and fusion. This is all about chapter nuclei. Okay, so now first, size of the nucleus. You know, this is atom, the central part of the nucleus. The nucleus is very small size. It is in Fermi, whereas it is in angstrom. Angstrom means 10 to the power minus 10 meter, and the Fermi means 10 to the power minus 15 meter. Now, size of the nucleus, the radius of the nucleus is directly, try to understand, radius of nucleus is directly proportional to A to the power 1 by 3. A is mass number. So what is R1 by R2? A1. Yes? A1? 1 by 3. Second thing, volume is 4 by 3 pi r cube. Volume is 4 by 3 pi r cube. If you take cube of this, A to the power 1 by 3 into cube, it will be A. So volume is directly proportional to mass number. So what is V1 by V2? A1 by A2. Remember. Third one is nuclear density. Doesn't depend upon mass number. It doesn't depend upon mass number. So what is the ratio?
1:1.
Density 1 by density 2, 1:1. Whatever may be the nucleus, the ratio is always 1:1. All are having equal nuclear density. Okay, so but the question is like this. There are two atoms having mass number 125, another is mass number 8. Compare the ratio of the radii of the nucleus. This is radius of the nucleus. Here we are talking about nucleus, not the atom. The atom formula is different. Yes, it is A1 by A2 to the power 1 by 3. What is A1? 125 by 8 to the power 1 by 3. 125 means 5, this is 2. What is the ratio of the volume of these two nuclei?
125 is to 128.
Yes, it is 125 is to 8. What is the ratio of nuclear density?
1:1.
Nuclear density is
1:1.
1:1. Okay, next. How can you, what is mass defect? What is mass defect?
The difference.
No, first nuclear force. Nuclear force. Inside the nucleus, there are some particles known as nucleons. As like parent means both father and mother, nucleon means the particles present inside the nucleus. Which are the particles present inside the nucleus? Proton and neutron. They are combined named as number of, they are nucleons. If I say chlorine 1735, how many electrons are there?
17.
How many protons?
35 minus
Proton 17. And neutron is?
35
How many nucleons are there? 18. How many nucleons? 18. Nucleons, not neutrons. How many neutrons? 18. How many nucleons? 35. Okay. Now, in between them, three type of forces acting: gravitational force, electrostatic force, and nuclear force. Electrostatic force is repulsive. Gravitational force is attractive. It is observed that the electrostatic force is dominating. Electrostatic force is 10 to the power 36 times greater than gravitational force. Due to which, what happens? They have a tendency. Look at here. Neutron and neutron, there is no nuclear force. There is no electrostatic force because they are neutral. Proton and proton, electrostatic force exists, which is repulsive. It is calculated that repulsive is 10 to the 36 times stronger than attractive force. It means there must be some force which helps to attract them. That is nuclear force. What is that? Nuclear force. Now we are going to talk about the nuclear forces. What are the nuclear forces? First, exist between nucleons. That is either neutron-neutron, proton-proton, or neutron-proton. It is the strongest force in the nature. Strongest. It has, yes, it has.
It doesn't follow the inverse process.
Shortest range. It acts within few Fermi. Few Fermi. It acts within some Fermi. Fourth, doesn't obey
Inverse square law.
It doesn't obey inverse square law. इसका मतलब क्या है? As like electrostatic force is inversely proportional to R square, F inversely proportional to R square, but this law doesn't obey this inverse square law. Is it charge dependent? No, force is charge independent. कैसे समझते हो? ये चार्ज डिपेंडेंट होता तो न्यूट्रॉन न्यूट्रॉन के बीच में फोर्स कैसे लगता? उसका तो चार्ज है ही नहीं, तो इट इज चार्ज इंडिपेंडेंट. But spin dependent. It depends upon spin. What is the source of source? What is the source of nuclear force? Source is exchange of pi mesons. Actually, between proton and neutron. Proton and neutron are unstable. They can be interconvertible. Proton can be converted to neutron, neutron can be converted to proton. During them they exchange pi meson. Due to this tendency, the nuclear force exists. Then what is the shape of nuclear force versus distance graph? The graph is like this. This is nuclear force. This is distance. The graph is like this. This value where the देखो बच्चे, here it is below x axis, that is negative. Here force is negative. Negative means it is attractive. Remember. Here F is means repulsive. So nuclear force is attractive or repulsive or both? Both. Where this point, this is R0 is equal to 0.8 Fm, where force is maximum attractive. Force is maximum attractive. It is stable condition. So this is a graph showing the variation of nuclear force with distance. Second one is nuclear potential energy. What I told?
Nuclear potential energy. Same.
Yes. Also same. This is 0.8. Okay. Nuclear potential energy versus distance graph. The distance is 0.8 Fermi. Okay, is it clear? Nuclear force. Now come to mass defect.
The difference between calculated mass and
Yes, very good. What is mass defect? Now suppose these are the proton and neutrons. We can calculate their mass. Mass of one proton into number of protons. Calculate mass means Z into MP. Why Z? Because element is represented like this, X, Z, A. What is Z? Atomic number. A? Mass number. A is not atomic number. So electron is Z. Proton is Z. Neutron is A minus Z. So here we are talking about nucleus. तो इलेक्ट्रॉन नहीं लेंगे, क्या लेंगे? प्रोटॉन एंड न्यूट्रॉन. तो Z into MP plus A minus Z Mn. What is Mn? Mass of neutron. MP. So this is calculated mass. Then the combined nucleus, it has some mass. The difference is known as mass defect. It is observed that the combined mass is slightly less. So delta M is equal to ZMP plus A minus Z Mn minus N. The mass defect is the difference in mass of calculated mass of free nucleons and the nucleus. So what is mass defect? Bolo? It is difference in mass of difference in of
calculated free electron.
difference in calculated mass and the combined nucleus. Calculated mass of nucleons and combined nucleus and nucleus. Yes. ठीक है? तो ये मास गया कहाँ?
स्पिन में रिकॉर्ड.
The mass is converted to equivalent energy known as binding energy. Now what is binding energy?
The energy that separate the nuclear.
Very good. Inside the nucleus, proton, neutron are there. They bound with each other with some force, with some energy. तो उतना एनर्जी हम दे देंगे, वो ब्रेक हो जाएगा. तो इन अनदर वे बाइंडिंग एनर्जी, द मिनिमम एनर्जी रिक्वायर्ड टू ब्रेक द न्यूक्लियस. दोबारा बोलो. मिनिमम एनर्जी रिक्वायर्ड टू ब्रेक द न्यूक्लियस.
To separate the
हाँ, वेरी गुड. एनर्जी कहाँ से आया ना? डेल्टा एम इज कन्वर्टेड टू बाइंडिंग एनर्जी. तो व्हाट इज द फॉर्मूला फॉर बाइंडिंग एनर्जी? तो बाइंडिंग एनर्जी इज इक्वल टू डेल्टा एम इंटू सी स्क्वायर. दिस इज आइंस्टाइन मास एनर्जी रिलेशन. Energy is equal to mass defect into c square. And you know, 1 m is equivalent to how many mega electron volt? कोई बता पाएगा? हाँ, 931.5 मेगा इलेक्ट्रॉन वोल्ट. मालूम है?
Yes.
तो भैया 0.5 आया. Then what is binding energy?
0.5
Into कर दो. तो इसलिए binding energy is equal to mass defect in atomic mass unit into 931.5 mega electron volt. And last one is binding energy per nucleon. क्या कहा मैंने? Binding energy per nucleon. मतलब एक न्यूक्लियन का कितना एनर्जी होगा. तो बाइंडिंग एनर्जी पर न्यूक्लियन इज इक्वल टू बाइंडिंग एनर्जी बाई मास नंबर. मास नंबर क्यों डिवाइड किए? दिस इज द नंबर ऑफ न्यूक्लियंस. जैसे व्हाट इज पर कैपिटा इनकम, मतलब एक आदमी का कितना इनकम है। सपोज एक आदमी, एक फैमिली में 1 लाख हुआ, उसमें 4 मेंबर है, डिवाइड बाई कर दें। सिमिलरली समझ में आएगी नहीं। तो बाइंडिंग एनर्जी पर न्यूक्लियन, बाइंडिंग एनर्जी बाई मास नंबर। क्वेश्चन में जो दिया हुआ रहेगा, हाउ कैन यू फाइंड द मास नंबर। देखो इन क्वेश्चन इट विल बी गिवन, सपोज इट इज लाइक दिस, सपोज देखो मास ऑफ प्रोटॉन मीन्स मास ऑफ हाइड्रोजन एटम, it will be given, mass of neutron be given, and mass of the nucleus must be given. If you see one question, it is like this. You see, this is iron having mass 55.934393 U, and mass of proton is this, mass of neutron is this. What is atomic number?
26.
Mass number 58, 56. So what is mass defect? You can say yes. ZMP plus A minus ZMN minus Z is 26 into 1.007825 plus 56 minus 26 into this is the mass of neutron. And what is this? 55.9349, mass of the nucleus. Then calculate it, it is in U, 0.52848 U. Then how much energy is released? Into 931.5 mega electron volt. आ गया? So in this way binding energy is this. What is binding energy per nucleon? You just divide the number of nucleons. A 36 divide कर दो. Clear or not? Okay, last one is binding energy per nucleon versus mass number graph. Yes, this is the binding energy per nucleon with mass number graph. From the graph explain nuclear fission and fusion. पहले what is nuclear fission? Fission मतलब breaking of nucleus. What is nuclear fusion? Combination of nucleus. In which case energy is released? In both the case energy. In which case the binding energy per nucleon increases? Both the cases. Why do they undergo fission and fusion? To increase their energy, binding energy per nucleon, so that they become stable. Okay? So ग्राफ कैसे ड्रॉ करोगे? देखो वन टू थ्री फोर फाइव सिक्स सेवन एट एंड 9. This is binding energy per nucleon. This is mass number. 8 में एक लाइन ड्रॉ कर देना. ओके, mass number, let this is 200, half is 100, half is 50, I need 56, half is 25, I need 30. Here middle is 150, I need 170. Okay, so 30 correspond to 30, this is a point. Correspond to 56, this is a point which is just below 9, it is not 9, rather it is just less than 9. 30 and 56, last one is 170. Graph starts from H11. Yes, this is the graph. 6 क्रॉस किया थोड़ा नीचे आया, 7 क्रॉस किया थोड़ा नीचे आया, 8 क्रॉस किया फिर थोड़ा नीचे आ गया, फिर 30 में जो 30 था 30 में क्रॉस करके ऊपर चला गया, 56 में हाईएस्ट, उससे ज़्यादा नहीं होगा, वहाँ से डिक्रीज हो गया। ओके, यू ऑब्जर्व फ्रॉम 30 to 170, from 30 to 170 binding energy per nucleon is constant. So constant means they are stable. Greater the binding energy per nucleon, more is the stability. So they are stable, they do not undergo fission nor fusion. ठीक है, तो फिजन कौन करेगा ना, जो अनस्टेबल है। अनस्टेबल कौन है, जिसका बाइंडिंग एनर्जी कम है। किसका कम है, ए लेस देन 30 एंड ए ग्रेटर देन 170। ओके, अब क्वेश्चन है व्हाई स्मॉलर न्यूक्लियाई अंडरगो फिजन। पहले हम बात करेंगे ए लेस देन 30 के लिए, स्मॉलर न्यूक्लियाई। इन केस ऑफ स्मॉलर न्यूक्लियाई द साइज इज स्मॉल, साइज इज स्मॉल। Which force is dominating? आपको मालूम है which is stronger force? Nuclear force. Nuclear force is attractive, electrostatic force is repulsive. Which is dominating?
Repulsive.
Which is dominating? Okay, so size is small. So in this case, the neutron and proton are very much closer to each other. That's why attractive nuclear force is dominating. So due to attractive dominating force, attraction ज़्यादा, so they have a tendency to combine. Smaller, they have a tendency to combine. So they undergo what? Nuclear fusion. So they show fusion. Now what happens with the element having mass number greater than 170? They are large in size. Some of the neutrons are away from the range. तो which is dominating here? तो रेंज ज़्यादा हो गया तो न्यूक्लियर फोर्स कम हो गया, तो रिपल्सिव इलेक्ट्रोस्टैटिक फोर्स इज डोमिनेटिंग। साइज लार्जर, तो रिपल्सिव इलेक्ट्रोस्टैटिक फोर्स इज डोमिनेटिंग। So due to repulsive electro-dominating force, they have a tendency to break. Tendency to break. So they show fission. Okay.